Good evening, ladies and gentlemen. My name is Joshua, and I'm from Computer Science, FICT. I'm currently taking a year 2 semester 3, and now I would like to bring to you my presentation for my final year project titled Low Cost Haptic Device. So before we begin, let's talk about what haptics is. Simply put, haptics is the younger sibling of virtual reality. You see, virtual reality actually started having its research and ideas done back in the 1970s, and haptics only started gaining traction in the late 1980s and early 1990s. In fact, haptics actually only have started having a highly extreme development starting in 2013, whereas virtual reality actually began commercializing to the public in 2010. So how does haptics work? Haptics actually gives us the sensation of touch. So when we talk about how haptics works, haptics acts as the intermediate between us humans and our virtual object. You see, where virtual reality provides us with visual simulation and auditory simulation through headphones, haptic devices gave us the ability to feel touch sensations of virtual objects. When we look at this slide over here, you can see that haptics is the intermediate device between machine and human. Through haptic devices, they both achieve similar functions of sensing the object, touching the object, and notifying our brain or the computer, and having corresponding motor reflexes to navigate and interact with the object. So like I said before, haptics only began going into research at 2013, around 3 years after virtual reality actually became popular with the public. So when it actually started going into the research phase, not a lot of companies spent much money into developing a full range haptic devices. In fact, most companies are geared towards haptic feedback controllers with force feedbacks or tactile feedbacks. This results in non-full range controllers that are applied with haptic sensations. However, these controllers don't necessarily get great attention, and it raises the question, where does haptics go now? Because when we look at the market, very little haptic devices are available for purchase, and most of them are controllers instead of full range haptic systems where you can actually interact with an object like you would with real life, like holding a ball, and your hand would just stop as the ball is in your hand. And when we look at this slide here, we can see that iPhone XR actually has a haptic touch interface, and it actually raises questions by its users whether it's a downgrade or an upgrade from its previous system, the 3D touch, because they notably loses a lot of functionalities when compared to 3D touch. And moving on, the Phantom Omni 3D systems is also another notable system. It actually provides us with a full-scale haptic interface in a pen type device. Yeah, it would be like using a pen in real life to interact with an object. And Phantom Omni 3D system stylus is capable of achieving exactly that. But then again, when we move on to look for further devices, we would actually find more controllers such as this one, the ET haptic tactile feedback controller. It boasts haptic tactile feedback on the palm grips, but it does not provide you with the actual ability to hold onto an object in virtual reality as you would with real life. In fact, there are certain suits such as this Tesla suit, currently still in development, that provides us with tactile force feedback sensations on a lower scale, where, for an example, if you were to bump into a chair in virtual reality while wearing this suit, you will feel the bumping sensation on the parts of your body, but it does not provide us with that force where you would flinch as you are bumping into a hard object due to its developments. Because of the current situation of haptic device research, we actually see several companies such as this one, Heartlight VR, one of the leading research developers of haptic devices, actually closing down due to lacking in terms of funding to continue its research. So it really gives us the question, where can we actually go along with haptics now, since haptics really does not seem to be consumer friendly as of late. Most of these devices we see are either controller based, or when we are talking about full scale haptic devices, it's actually very expensive to purchase, such as this haptX gloves, costing $5,000 a kit, and it's only available from ordering from its company developers directly. Whereas the previously mentioned Phantom Omni, also known as 3D Systems Touch, it is you can only request for demos, and certain sources say that it costs 10,000 ringgit Malaysia to get one onto your own hands, the full system, and the maintenance cost is also very expensive. Therefore, in this proposal, I would like to propose to create a low-cost haptic devices based around the Phantom Omni or 3D Systems Touch, to create a low-costing haptic device that would be able to be implemented to our daily lives, and actually lowering the cost so that more research can be done and more people around the world can collaborate onto it, such as when people are developing the Java language. In fact, I would propose that my 3D systems would be having 3 degrees of freedom, just as the Phantom Omni, to be able to interact with an object using a stylus. To create that, I would have to be able to create a base that can have a limited amount of mobility, around 270 degrees of movement in the front, controlled by a motor. And the arms and the nib of the prototype would also require motors to control around 180 degrees of free range movement, so that it can move around and touch an object within that space. This would result in a very limited, however, the target here is to be cheap, so that we can have more people developing on this device, that we can make it cheap and benefit the people around the places around here. So one of the materials I would like to use to create this prototype is to actually use 3D printing. Some of the more well-known 3D printing materials are such as the ABS and the PLA. Both of these are common materials. They are plastic, and they tend to be slightly more brittle, but that is a problem that can be overcome by condensing the insides of it so that it has less space and will become less brittle. And should the necessity arise, we can also move on to using SLA acrylic, which is a harder and much stronger material than previous two mentioned. However, there are also costings to consider as the acrylic is actually pretty expensive at 14 ringgit per milliliter at 100 mu, the density of it. And the last option we can actually take about is having metal printing. In fact, metal printing may be required to enforce the most important regions, such as the motor areas, to avoid the motors breaking down and actually hold on to it so that the structure doesn't fall apart as we are building up the prototype. Why use 3D printing? Let's say 3D printing is actually a very customizable method of building a prototype as well as a final product. One of the main reasons to make it is because it's cheap and it will be readily available to everyone in the world to actually build this prototype out on their own, following the instructions through using 3D printing and purchasing perhaps several motor parts and microcontroller systems. Besides that, 3D printed haptic device would also be pretty low maintenance, as any part that is broken, you can easily just directly replace it with a new part instead of having to send it back to factory. Therefore, not much expertise is required, and you can just do it at your home and don't need to be too much worried about how expert do you need or sending it through customer services. This way, more people can put in the effort, from their homemade workshops, to build up even further the haptic devices. That's all for my presentation. Thank you for listening. Once again, my name is Joshua, and this is my title, Low Cost Haptic Device, for my final year project. Thank you.